Our next problem is example problem number 2. Calculate the final temperature when 2 liters, and I like underlining things, at 21 degrees Celsius is compressed to 1 liter. So the first thing we're going to do is we're going to try to, as we read through that again, we're going to try to fill in the first step, which is list the variables. So 2 liters. Liters, that's a volume, so I'm going to put that as my initial volume of 2.0 liters. And then it says 21 Celsius. So I'll put that in my initial temperature. And it's then compressed. So after we have this initial set of conditions, it's compressed and it's now 1 liter. So they took whatever container and shrunk it in half. And so calculate the final temperature. So this again is what we are trying to find. That's your question mark. That's your X variable right there. So what we could do to solve this, since we know there's no pressure change at all, there's nothing that's happening with the pressure, we can cross these out. They won't matter. Okay. And then we go back and we look at our equation sheet. Is there a variable that relates volume and temperature? And there is. And so we've done the first half of this problem. And so now, that's kind of annoying, that squiggle's there. Now what we're going to do is we're going to find that equation. So the equation is V1 over T1 equals V2 over T2. Okay, we've just got our second point already and we haven't done any math yet. So the third step says, let's substitute those values in. So we've done, I'll write these down. Here's the L step. Here's the E step. Here's the S step. And we really encourage you to, as you go forward in your science career, to use this LESS method when solving any problem. It's a little bit more work, but you're always going to get as much credit as possible, and you're going to more likely get their answer correct. So let's substitute the volumes in. So 2 liters over, and then we have our temperature, and our temperature is in degrees Celsius down here, and we know we can't use Celsius, so we have to use Kelvin. So if you guys remember, to find the Kelvin equals degrees Celsius plus 273. So if you plug in that degrees Celsius, it's 21 degrees Celsius plus 273. So we know our initial temperature is going to be 294 Kelvin. Okay, so we've done this first part of the equation right here. Second part is then that all equals our second volume, which is 1.00 liters, divided by our unknown, our mystery, our T2. So before we did the cross multiplication method where we took this number, we multiplied it by this number, then we divided it by this number, and that gave us this answer. And I like doing this little kind of this times this gets us that. And that's the cross multiplication. Another way you could do that is a little bit longer, but we can take and just divide these numbers right here. 2 divided by 294, and I'll do that on my calculator. 2.00 divided by 294 equals 0.0068. And that's going to equal 1.00 liters divided by question mark, or your T2. So now, again, you could pause and see if you could continue to solve that. If I want to get the question mark on the other side, if it's being divided on this side, I can multiply both parts of the equation by the question mark. Or I'd rather put in T2, but I just did it a different way this time. So that resolves to question mark times 0.0068 equals, these cancel out, 1 liter. Again, some of you might now see how to solve it. Question mark equals, you're going to divide both sides by 0.68. So you're going to divide it by 0.068 divided by 0.068. Oops. And you get, let me go, 1 divided by 0.0068, is 147. Okay, and again, what are my units? My units are K. So I'm going to circle that so I know that the question mark, which is really T2, I would have used T2 if I were doing this again, equals 147K. So if we track that, I'll show you how you get your points again. We look at the less method. Here was the second S. I solved for it. So I'd give you +1, +1, +1, and +1 down here. Now, if you had made a mistake at the earlier spots, we wouldn't double count that. So you would still get credit for most of the problem if you made maybe a mistake in identifying which variable was which. Let's do another problem. And if you're still watching this, one of the best things you could do for yourself is to figure out what step you are getting stuck on and then asking a friend or a teacher for help. So I'm going to read through this. I'm going to do it a little bit quicker, and we'll see if we can get the right answer. The goal would be that you would pause this video, you would try it yourself, and then go back over and watch it as, maybe you get stuck and see where you got stuck. So I'm reading this question, and I'm going to solve it. There's a highly toxic chlorine gas, that doesn't really matter, has a volume of 0.8 liters, so 0.8 liters at 250 Kelvin and 100 millimeters of mercury. Now, if I don't write all the zeros, that's just because I'm trying to do this a little bit quicker for you guys. What would the volume of the gas be at 500 K? So we're increasing the temperature, and since we know that when you increase the temperature, the pressure also goes up. Okay, and so we don't have this. So I'm going to call it V2, so it reminds us what we're solving for. Since we use all these variables, we're going to use the combined gas law, and the combined gas law is P1 V1 over T1 equals P2 V2 over T2. Okay, so now let's substitute them in. I'm going to work down just because I write big. 100 times 0.8 divided by 250 equals 600 times V2 over 500. Okay. Now, as I'm doing this, I already don't like the fact that I didn't put my units, but normally you would go in ahead and put your units in there. This one, we can solve a different way. So on the left side of the equation, we know we just have some numbers. So I'm going to just multiply and divide those numbers. 100 times 0.8 divided by 250. And that gets us 0.32. And that still equals 600 times V2 over 500. Well, 600 over 500 is just a number as well. So if we do that, 600 divided by 500 is just 1.2. So I can keep simplifying this. 0.32 equals 1.2 V2. Then you can continue solving for V2. You have to divide both sides by 1.2. And you're left with V2 equals 0.32 divided by 1.2. 0.27 liters. It's a volume, so it's liters. So I'm now not using boxes. If I had more space and I wasn't doing this on an iPad, I would use boxes. But I'm going to circle again the less method. We listed out the variables. We wrote the equation. So there's my L, there's my E. I substituted them in. So that's my first S, and I solved for it. That's my second S. And you're getting 4 points for doing all this work. And of course, we just won't give you so many problems to solve because it does take you a couple minutes to solve this. I'm going to go ahead and solve the other one really quickly. Pause the video, try to solve it, and we will come back. Now, I just worked out the problem for you guys, and I'm going to just go through and circle the less method for you of what we expect. There's the L. So you listed all your variables. If you notice, the volume is 500 milliliters. It's just best practice to then change that to liters. So if you see later on the calculations in liters, that's what we did. Here's the formula. We needed this combined gas law because we had all of the different variables right here. Then we substituted the numbers in and solved it. And the amount of liters really dropped, which might not make sense at first, but if you look at it, it's the temperature divided in half, but the pressure went up. And so if the pressure is going to go up, that volume had to go down to allow for the math to work out. So the new volume is 0.009 liters. I hope these example problems helped. Like I said, there's a couple of ways to mathematically solve them, so you're going to have to find the way that you know and best works for you and get help with that if you're struggling. Otherwise, using the less method is key, and rereading the question twice to identify those variables also helps. Hope you enjoyed the video. Let me know if you have any questions.